Hello students, this is a continuation of our previous video where we are finding the optimal transportation cost of the given matrix. Now here the problem is we have to find the optimal transportation cost for which we will be applying the vogels approximation method followed by the modified distribution method shortly known as Modi's method. Now here the matrix given first we will be writing, and by using the Vogel's approximation method we have evaluated the allotment table, and after finding the allotment table we checked whether the solution is degenerate or non-degenerate by using this, that is m plus n negative 1 is equal to number of allocations, and we found that the solution is a non-degenerate basic feasible solution, after which we have evaluated the total cost, that is we have got it to be 779 units. Now we have to check whether this basic feasible solution is the optimal solution or not. To do so, we have to use the modified distribution method shortly known as Modi's method. So let us do that now. Now by the Modi's method, here we have this method. When can this method be applied? This method is applied to find the optimal transportation cost. That is why this method is applied, to find the optimal transportation cost. And when can this method be applied? It can be applied only if m plus n minus 1 is equal to the number of allocations. That is, the solution, the basic feasible solution has to be a non-degenerate basic feasible solution. If so, we can proceed the problem to find the optimal solution. So there are various steps involved in finding the optimal solution. Let us see that one by one now. The first step is the evaluation of ui plus vj for occupied cells. Now what are these occupied cells? Now in the allotment table that we have obtained, this is the allotment table that we have obtained. In that, the cells which have been allotted are known as occupied cells. And what is this ui plus vj? These are the cell values of the original given matrix. So this is the original given matrix. The cell values are represented as ui plus vj. Now we are going to find ui plus vj for the occupied cells, that is these are the occupied cells. Now for these cells we will be finding a new table where we will be replacing these values by the original cell values of the given matrix, that is at the place of 5. We have to check what is the original cell value. It is 19, so 5 has to be replaced by 19. Similarly, in the next allocation, here we have 2, that has to be replaced by the original cell value 10, and for the next allocation 7, it has to be replaced by 40, 2 has to be replaced by 60, 8 by 8, and 10 by 20. Now here we have done so, and we have got the new allocated cell values. Now if you see here, in the allotment table we have replaced the allocations by the original cell values for the occupied cells. Okay, other cells are as usual, they are hyphenated. These cells are known as unoccupied cells. They have to be hyphenated, and the occupied cells has to be replaced by the original cell value, which is known as ui plus vj. Now after doing so, the rows has to be named as u1, u2, u3, and the columns has to be named as v1, v2, v3, v4. That is, these are ui's where I takes the value 1, 2, 3, and these are vj's where j takes the values 1, 2, 3, 4. Now after naming the rows and the columns, we have to form equations. Now how the equations are formed, let us see. The first equation is formed by considering the first cell value. Now what is the first cell value here? It is 19. Now this 19 has to be written as, now here the corresponding row is u1 and the corresponding column is v1. So now what we have to do, u1 plus v1 is equal to 19. So that we have to write. So I have written here. Next, for this value, the corresponding row is u1. The corresponding column is v4. So u1 plus V4 is equal to 10. So that I have written here. Similarly, U2 plus V3 is equal to 40. Then U2 plus V4 is equal to 60. U3 plus V2 is equal to 8. And then U3 plus V4 is equal to 20. So this has to be 20. So this is 20 actually. So now we have to form these equations. Now what is the purpose of forming these equations? We want to evaluate each ui's plus vj's. That is, we want to evaluate the value of u1, u2, u3 and the value of v1, v2, v3, v4 separately. So now to evaluate that, we have to assume one of these values to be 0. But how to choose that one value to be 0? Now we have to check for maximum allocation. Now how many allocations the row u1 has? It has 2 allocation. U2 has 2 allocations. U3 has 2 allocations. V1 has 1 allocation, V2 has 1 allocation, V3 has 1 allocation, V4 has 3 allocations here. Now which variable had the maximum number of allocation? V4 had 3 allocations. So we have to assume V4 to be equal to 0, and using that we have to evaluate the values of other variables. So now if you see here, we have to put V4 to be equal to 0. So here I have put V4 to be equal to 0. Now in these equations, we have to check where all this V4 appears. Now if you see, V4 appears here and then here and then here. Now in those places we have to put 0 because we have chosen V4 to be 0. So if we put V4 0 here, U1 will be equal to 10. So that I have written here. If you put V4 0 here, we will get U2 to be equal to 60. So I have written that here. Then again V4 here we have. So if we put 0, U3 will be equal to 20. Now we have evaluated U1, U2, U3. Now what are the variables left out to be evaluated? We want to find V1, we want to find V3 and we want to find V2. Now to find V1, we have to substitute the value of U1 that we have found. U1 is what? 10. So 10 plus V1 is equal to 19. So that I have written here. 10 plus V1 is equal to 19. So what will be the value of V1? It will be 19 minus 10. So V1 is equal to 10. So V1 is evaluated. Next we should come to evaluation of V2 we will do. So this equation we will take. Now U3 plus V2 is equal to 8. What is U3? U3 is 20. So 20 plus V2 is equal to 8. That I have written here. 20 plus V2 is equal to 8, from which V2 will be equal to 8 minus 20. So V2 is equals to 8 minus 20 will be minus 12. So that we have written here. And the last that we are going to evaluate is V3. That is U2 plus V3 is equal to 40. Now what is U2? U2 is 60. So 60 plus V3 is equal to 40. So I have written that here. 60 plus V3 is equal to 40. So V3 will be equal to 40 minus 60, and so V3 is equal to minus 20. Now we have evaluated all the values of U1, U2, U3, V1, V2, V3 and V4. So let us all write it together now. So now we have taken and written all the values of U1, U2, U3, V1, V2, V3, V4. Now step 2 is to evaluate UI plus Vj for unoccupied cells. Now this is very important here. These are unoccupied cells we are going to fill now. So what will happen to the occupied cells? We have to hyphenate the occupied cells. That is, if you check here, these are the occupied cells. That is this 19, 10, 40, 60. First step is we have to hyphenate these places. So all the occupied cells has to be hyphenated. So we have 19 here. So let us hyphenate it. And then at this place we have to hyphenate. And then here these two has to be hyphenated. So these two. And then these two boxes cells has to be hyphenated. So hyphenate this. Now we are going to fill these cells. Now how to fill these cells? The cell evaluation for this unoccupied cell is the addition of u1 plus v2, the corresponding row and the corresponding column. So here what we have u1, here we have v2. So what is the addition of u1 and v2? So if you check here, u1 is 10, v2 is minus 12. So we have to, here I will write, okay. So we want u1 plus v2, which will be equal to what? 10 plus v2 is minus 12. That is 10 minus 12. And so that will be equal to minus 2. So this place we have to write minus 2. Now next this cell is what? u1 plus v3. So we have to write u1 plus v3. But what is u1? It is 10. So 10. And what is v3? Minus 20. So minus 20. So what is 10 minus 20? It is minus 10. So this cell is minus 10. So similarly we have to fill this cell. It is this cell now. So u2 plus v1. So that is u2 plus v1, which is equal to u2 is 60. Okay, so 60 plus v1 is 10. So 60 plus 10, which is equal to 70. So this cell is 70. Now what about this cell? It is u2 plus v2. So u2 plus v2. What is u2? u2 is 60 plus v2 is minus 12. So 60 minus 12, which will be 48. So this will be 48. Now this cell is u3 plus v1. So u3 plus v1, which is equal to u3 is 20 and v1 is 10. So plus, see here, v1 is 10. So plus 10. So that will be equal to 30. So this cell will be 30. And the last cell left out here is u3 plus v3. And so u3 plus v3 is equal to, what is u3? 20. And then v3 is minus 20. So 20 minus 20, which is 0. And so this cell is 0. So now we have evaluated ui plus vj for unoccupied cells. Now next we have to find the del ij's. So let us see how to find that. Now let me tell you about this del ij. The evaluation of del ij is done by cij minus ui plus vj. So what is the Cij? This is the cell values of the original given matrix minus this ui plus vj is the recent matrix, okay, last matrix that we have evaluated for the unoccupied cells. So when we find that matrix and if all the elements of this del ij matrix is greater than or equal to 0, then the initial basic feasible solution will become the optimal solution also. So that will be the optimal solution. But if this del ij is lesser than 0 for any one cell also, then we have to proceed for another iteration by following few steps. So these are the two ideas that we have to remember. So if it is greater than or equal to 0, that is if it has all positive values, then the basic feasible solution will be the optimal solution also. But even if it has one single negative value for any cell or more than one, then we have to proceed further with the problem. So now let us evaluate this del ij for this matrix and let's check in which category it falls under. So del ij is evaluated by Cij minus ui plus vj. As I told you, ui plus vj is this table. Now the Cij is the original cell value of the given matrix. That is, these values are the Cij values. Now if you see here, the first place is hyphenated. So we have, this is the new table for evaluation of del ij. So this we have to hyphenate. Now in the second place we have minus 2. Now what is the original cell value? It is 30. So 30 minus of minus 2. So 30 30 minus of minus 2 will be plus 2. So 30 plus 2, that will be 32. So here we have to write 32. Now here we have another value. Okay. Now if you see, the original cell value is 50. So 50 minus of minus 10. So 50 plus 10, which will be 60. Now here it is hyphenated, so we should hyphenate here also. Now this is 70, and here the original value is also 70. So 70 minus 70 will be 0. Now next here we have 30, and here we have 48. So 30 minus 48, which will be minus 18. Okay, and then these two places are hyphenated, so let's hyphenate it. And now the last row. So here we have 30, and here we have 40. Okay, so 40 minus 30 will be 10. Then hyphenate, and here we have 70, if you see. So 70 minus 0. So it will be 70, and then hyphenate it. Now if we check here, all these values are positive, but there is one value which is negative in del ij. And what I told you, even if there is one negative value, then the initial basic feasible solution is not the optimal solution. We have to proceed the problem further to find the optimal solution. So let us see how to do that now. Now in this del ij, we must check which is the most negative value. Now because here we have only one negative value, so we shall consider this. But if it is more than one negative value, we have to consider the one which is most negative. So now here we have negative 18. So in which cell it is? It is in the second row, second column. Now what we have to do? We have to take the first allotment table that we have obtained and locate this second row and second column. Same cell we have to locate here. So this cell we have to locate first. Now what we have to do is, we have to draw a closed loop starting from this cell, whose other corners will be occupied cells. Now from this, we have to come back to the same cell by drawing a loop, and that loop should be we have to draw in such a way that it has to be the shortest loop, and we have to come back to the same position, that is the same cell. Now from this cell, if you see, these are hyphenated cells, so we have to move to a cell which has to be an occupied cell. Now if you see, we can move directly here. So from this cell, we can directly move to this cell. Now from this occupied cell, I can come back like this. I can travel like this, and from this cell, I can move to this cell, and from here I can again reach to the original position. The idea is the loop has to be shortest, because if I move from here to here and then from here to here, it will be unnecessarily another one cell we will be crossing. So we will be halting in this cell. It's not necessary, because we have another occupied cell here to which we can directly move on. And from here, if I move to this direction, then from here I have to move to another occupied cell. And if I see, I cannot go further to reach this point, so I choose to turn here. So after this cell, I can move here and I can directly come to this position. So now what I have to do is, I have to enter a positive sign at this place, and alternatively with a negative sign here. If this is negative, alternatively this has to be positive, and this is positive, so alternatively this has to be negative. So now we are going to form a new allotment table. Now how we are going to do that is, out of the marked positions, which value is the least value we have to choose. The least value that we have to choose is, because here it is 8, 10 and 2. Out of these three values, 2 is the least value. So this value we have to choose. And at these points we have to, like for example, here we have a plus sign. So at this point we have to add it. So here we have to subtract, here we have to add that 2, and here this place, the value that we choose, that has to be hyphenated. The cell which we choose, from which the value that we choose the least value, it has to be hyphenated. So remember this and form a new allotment table. Now here we are going to write the new allotment table, for which we have to consider this. So what is the first value? It is 5. So that will remain the same. And here hyphenated, and here we have 2, and here hyphenated. And now for this cell we have to add 2. I told you, out of these three values we have to select the least value is 2, so the 2 has to be added at this position. So here it will become 2. The 7, it will remain the same because there will be no change in it. And for this 2, the value that we select, it has to be hyphenated. And then after that, here it is minus. So 8 minus 2, which is 6. And this is hyphenated, and here we have plus. So 10 plus 2 will be 12. So this is our new allotment table. And this allotment table is obtained by adjusting the allocation by drawing a loop. Now next we have to proceed with this allotment table. We should do the same procedure, and now we have to find the total cost for this, and then we have to apply Modi's method to check whether that cost is the optimal solution or not. So that we have to check now. So we have to follow the same procedure. So first we will find the total cost by using these allocations. Because this is a new allotment table, the method is same. We have to multiply 5 with the original cell value plus 2 multiplied with the cell value plus like that. So let's find the total cost. So now this is the total cost that we have obtained. So I have evaluated using the same procedure, and I've got it to be 743 units. Next again we have to check whether the solution is degenerate or non-degenerate. So m plus n minus 1 was equal to 6, and number of allocations, if we see, 1, 2, 3, 4, 5 and 6. So both were equal. Now we have to check whether this solution is optimal or not. Okay, now the same procedure what we did before, we have to continue with it. So first we have to move on to this test for optimality by using the Modi's method. So what is the first step? To evaluate ui plus vj for occupied cells. That is, at these places we have to replace it by the original value from the given table. So at these places, if you see, we will be having 19. You can check with the cost matrix that is given in the question. So this will be 30, 40 and dash 8 hyphenated and 20. So these are the cell values of the original cost matrix. So we have replaced it. After that, what we will be doing, we will be forming the equations, if you remember. So u1 plus v1 is equal to 19. So u1 plus v1 is equal to 19. u1 plus v4 is equal to 10. And then u2 plus v2. So u2 plus v2 is equal to 30. And then u2 plus v3. So u2 plus v3 is equal to 40. And then what we have, u3 plus v3 is equal to, v2. So u3 plus v2 is equal to 8. And then u3 plus v4. u3 plus v4 is equals to 20. Now using these equations, we have to evaluate each u1 and u1, u2, u3, v1, v2, v3, v4. Now we have to check for maximum allotments. Now if you see here, there are 2 allotments, 2, and here also 2. Here it is only 1 allotment, 2 allotment, 1 allotment and 2 allotment. So if you see, maximum is 2 allotments only. So we can choose any variable as 0, whichever has 2 allotments. So I am choosing u1 to be equal to 0. So if I choose u1 to be equal to 0, what are the equations that has u1? This and this. So directly when we put 0 here, v1 will be equal to 19. Okay. And then v4, because this is 0, v4 will be equal to 10. So we have assumed u1 to be 0 and we have obtained these two. Now wherever v1 is available, let us substitute that and we will obtain the other value. So if you see, v4 is available here. So when we substitute 10 here, so u3 will be equal to 20 minus 10. So u3 will be equal to 10. So similarly, doing like this, we have to evaluate all the other remaining values. So we have evaluated all the remaining values in the same method, and I have taken and written u1, u2, u3, v1 to v4 over here. Now we have to move on to step 2. Step 2 is evaluation of ui plus vj for unoccupied cells. So the occupied cells has to be hyphenated now, and the unoccupied cells has to be filled. So let us do that now. So now using these values of ui's and vj's, we have to evaluate ui plus vj for the unoccupied cells. So the occupied cells will be hyphenated. For example, this value will be u1 plus v2. What is u1? It is 0. v2 is minus 2. So 0 minus 2, it is minus 2. This is u1 plus v3. u1 is 0. v3 is what? 8. So it is 8. So like that we have to fill the other cells also. Now after finding this, the third step will be to evaluate del ij. So that we are doing here, to evaluate del ij by using the formula del ij equal to cij minus ui plus vj, which I have already explained it to you. And then using that we have evaluated the new del ij values, where what we will be doing is cij minus this. So cij, the original cell value, minus this value is 32, because the original cell value over there is 30. So if you see here, it is 30. So 30 minus of minus 2. So it will be plus 2. So 30 plus 2, it is 32. So like that we have evaluated all the del ij, and we observed that all the del ij's are positive. There is no negative value. Then we can conclude that the second allotment table, which gave us the solution 743, is the optimal solution. So we need not reduce the transportation cost further. So this has given us the optimal solution. Hope you have understood this problem. Thank you.